Okay, so up here I have the example of the series parallel circuit. So this isn't exactly what's on the assignment, but it gives you guys the concept. And I've gone ahead and labeled my resistances on there, and my voltage is 5 volts like we've done for all the other circuits. So using the guess technique, once again, like I taught on the other ones, if I go ahead and start with my givens, I know that my voltage total equals 5 volts. I also know that my resistance of resistor 1, I suppose that should be labeled 1, is 100 ohms. Resistor 2 is 200 ohms. Resistor 3 is 300 ohms. Resistor 4 is 400 ohms. And resistor 5 is 500 ohms. So then what I'm looking for is there's a few different things I need to look for in this circuit. In the activity, it tells you to go ahead and just find resistance total and current total, which means that you don't have to solve for everything. Would you guys like me to solve for everything so you see how to do it? Okay, looks like you guys want to see how to do everything. Let's go ahead and start our unknowns with our resistance total and our current total. So we'll go ahead and start by solving those, and then we'll take it from there and look at the other items that we're dealing with. So if we look at resistance total, I told you guys earlier that this section right here in series is going to work in parallel with resistor 2. So I know that resistor 3 plus resistor 4 equals my total resistance in this leg, which is going to be easy enough for me to add up as 700 ohms. Now once I've done that, I need to go ahead and do it in parallel with this section right here. If I was using my equations, I'm using V equals IR. I'm also using my two resistance equations for series resistance and parallel resistance. So in this example, my parallel resistance, I've got 1 over R2, which is 200 ohms, and 1 over my R3 plus my R4, which is 700 ohms. And this is just so I can figure out this leg of it over here. So if I go ahead and plug that in the calculator, and then I take the invert again, I find that those two legs have approximately 155.6 ohms. And remember, when we're dealing with a parallel circuit, one way that I always double check is that resistance should be less than my smallest resistor, which in my example is 200 ohms. Now that I have that, I can go ahead and solve my resistance total, because I know that this whole section here has that resistance of 155.6 ohms. So now my resistance total is 1 over R. Now, my resistance total is a series circuit now, so it's R1 plus resistance of dotted area, I'm going to just put that R sub D, plus resistor 5. So R1 is 100 ohms plus 155.6 ohms plus 500 ohms, which should be 700. Resistance total equals 755.6 ohms. So I can put that down here for my resistance total of 755.6 ohms. Any questions so far? Okay, so I had to work a couple ways there. I did a series circuit, found my resistance there, worked it with my parallel leg to find the resistance of that in section, added all of my resistances together to go ahead and get my resistance total. Then, current total should be fairly easy, V equals IR. I'm dealing with total voltage, which is 5 volts. Current total is what I'm looking for, and my resistance total is 755.6 ohms. So I just take my 5 volts, divided by 755.6, and I find my current total to be 0.0066 amps. which if I convert it to proper SI units would go ahead and be 6.6 milliamps. Now that's all the further you had to go for the assignment. If we want to go further, what we can go ahead and do is we kind of have to work backwards through it. So we know that this is in series with all of this, which is in series with this. In a series circuit, what stays constant? Current stays constant in a series circuit because we have voltage drop. So we know for resistor 1 that our current is what we calculated. We also know for resistor 5 that our current is what we calculated. So we could go ahead and use V equals IR, and we could solve for our current at resistor 1. So if we're doing that, I take that back. We could solve for our voltage drop across resistor 1. Because we don't know that, we're looking for our voltage at resistor 1 equals our current total, because it stays constant in a series circuit, times our resistance, which is 100 ohms. I think I can even do this without a calculator. So if I go ahead and move that 2 places, that means that I'm going to go ahead and have 0.66 volts is my drop right there. Same way with resistor 5, V equals IR. I know that I'm looking for my voltage at resistor 5. I know that it's equal to my current times my resistance. Just to make sure I do it correctly. We go ahead and have a voltage at resistor 5 equal to 3.3 volts. Okay, so those are the easy parts. Now we have to go ahead and get a little trickier when we go a little further on. So we know that this total circuit right here has a total resistance of 700 ohms. We know that the current throughout that entire circuit is going to go ahead and be the 6.6 milliamps that we're used to. But we have to go ahead and break that down because it's in parallel, right? So we've got 2 parallel sections. In parallel, our voltage stays constant, right? So in parallel, our voltage is constant. We need to find the voltage inside that whole circuit. We could do it 2 different ways. We could calculate V equals IR, or we could use Kirchhoff's law to go ahead and do it. So I'm going to do the V equals IR. So I'm going to go ahead and take the voltage of my block. I'm going to use that same subscript. My current is still 0.0066 amps. And I take it times my total resistance of that block, which is my 700 ohms. No. What was my mistake there? 700 ohms is just this piece. My total resistance of that block is 155.6. So times 155.6 ohms. So then I find my voltage drop across the block is 1.03 volts, approximately. So that goes ahead and tells me that everywhere in this section, this leg and this other leg are both the 1.03 volts. Now that I have that, I could find my current drop across this portion because our current changes in a parallel circuit. So I could find my current drop across that portion. So if I want to go ahead and find, I know my voltage is 1.03 volts is equal to, I'm dealing with resistor 2, I'm looking for current drop, times my 200 ohms. So I take my 1.03, divide by 200, and I find that my current drop there is 0.00515 amps, or I could go ahead and say that it was 5.15 milliamps. Okay, so now I've got that information 0.4 resistor 2. Remember, I'm kind of dealing with these two together, so I need to go ahead and find the current for those two. Once again, I could use Kirchhoff's law, or I could go ahead and use the same type of calculation to find their current, so that I can once again go a step further and find the voltage drop across each of them, because they are in series, so they have voltage drop. So if I go ahead and find the current for them together, 1.03 volts equals current across resistor 3 and 4, times my total resistance was 700 ohms when I added them together. So once again, I can take my 1.03 and go ahead and take it divided by 700, and I get my current across resistor 3 and 4 is equal to, once I go ahead and convert to proper SI units, 1.47 milliamps. Now just to kind of double check that, current should add up to the same as the circuit current. So if I look at this number plus this number, I've got about 6.6 milliamps, which matches my current total, which tells me that I calculated that leg correctly. Now keep in mind, this is more in depth than what you had to do for the assignment. I'm just going through it so you understand it. Now that I have that current total, now I can solve, or that current total for this little leg, I can solve my voltage drop across resistor 3 and resistor 4. So voltage at resistor 3 equals 0.00147 amps times 300 ohms. And my voltage drop across resistor 3 is approximately 0.441 volts. And same thing for voltage drop across resistor 4. Is going to be 0.588 volts. Ideally, I'd probably convert those to millivolts, but I just want to go ahead and get through the example, not run out of board space. So if I'm looking at this, once again another check, Kirchhoff's voltage law, if I add these two up, should come up to my total of 1.3 volts that I need for that leg. And then if I add that 1.03 plus my voltage drop that I had on these other two, so my 3.3 and my 0.66, I should go ahead and come to my 5 volt total. It takes a little more calculation doing all of it, a little more in depth, but I want to make sure that I gave you guys the details of how to calculate the entire circuit in case you wanted to.